All right, MT-149. This is week 8 lab for the week. And now what I wanted to do is review the sequence valve. So this is something we're going to be doing next in lab. We've just started discussing sequencing and how pressure control is adjusted and say timing of one application to another, like a compress or clamp and drill circuit. So this is what we're going to talk about today: the clamp and drill circuit, and how to control that, right? So here, in order to do that, we need to talk about the sequencing valve. The sequencing valve is very similar to our relief valve. So the relief valve here, which I've already drawn, shows our spring here, and we have an adjustable spring. So the arrow goes through it to actually show adjustability, so we can change the compression on the spring, which changes the force to actually push this arrow up, connecting, which will eventually open up our connectors, right? Meaning pressure, essentially we have a pilot pressure line going here, going to our connector. So basically it's kind of like a pressure switch. So that pressure switch will move that spool into place, and then it'll open up the valve. Meaning if it's relief valve, that this exit here would go straight to reservoir. So anything, say, over a specific spring pressure, spring force, you could set that, and you would set that using your pressure gauges, right? That's how we've been doing in lab. But that'll open up your valve, and then any excess pressure over your set, say 300 psi setting, will then dump to the reservoir. Well, how this differs and I need to actually draw the spring chamber drain, right? So in a lot of cases, if it's just a relief valve, it might have an internal drain, which will look like something like that. So it's going to have a drain back to the hose that goes back to reservoir. In our case, we had 3 ports, right? We had the port that was here, so the connecting port that we connected to there, and the connecting port that we connected to here. This pilot line here is all internal to the system. So we had an external drain. The external drain would be shown something like this. I'll show an extra reservoir symbol, right? Means we only really have one, but it's a way to show that it goes back to reservoir. And also a way to show that it goes back to reservoir in a different section of the circuit. We could take that down right to our return line here, but this is another way to do that. Typically you'll see them with a quick drain. If it's a externally drained spring for your relief valve, you can then use it as a sequence valve. So that's why I'm discussing this. So that spring chamber, again, if we can externally drain it to a relief valve, we can also set it up to where basically that can operate at different pressures. And we'll discuss that more when we get into valves. I might discuss that actually, I think, next week when we start talking about pressure control. But here we have what's termed as a sequence or a relief valve, right? And this is externally drained here. So what I wanted to discuss today is how the difference is, though. So the sequence, you would say, have on this side a cylinder compress something until that reaches a certain pressure, a certain force, say a compression force. Once that, say, reaches 600 psi or whatever you want that compression force to be, then whatever's on the downside of this will then react and then extend, say, a drill to drill a hole, or say a punch press or something like that. So it triggers, you can end up doing triggering using sequencing of pressure control. So here I wanted to discuss how we could do that with our system, right? So let's start out by drawing the power source. So it's going to have a reservoir. It's going to go up to our pump. So notice how the arrow is pointed out and away from our circle. So that means we're pushing fluid out. And a lot of times they'll show, not always necessary in most cases because it's usually assumed, a little bit smaller circle on accident. Not necessary that that's typically the way to draw those, but that just means a motor is attached powering, so an electronic motor or gas powered motor, or some sort of drive motor is connected to your pump, driving the pump, right? And then we have fluid come out, and then we have our relief valve. So the box here, we have our arrow. Notice how it's not attached. It's not attached to that. Draw it a little bit further away so it doesn't look confusing. So it's not really attached there, right? So that is there, and then we have a pilot line coming off of, and this is all internal, so a lot of times when it's internal they'll show it like connected to the inside point there. And then we, on the other side, we have that spring, that adjustable spring, right? So there's the spring, and then you draw an arrow for adjustability. And then we have this drain. And that goes back to reservoir. And we could draw it that way, or again, if it's internally connected, so it's not an externally drained valve, it's going to look something like this. So it's externally drained, and then it goes out with the fluid back to reservoir. Right. So that's your basic hydraulic power system, supply system, right? And then it's typically in a certain enclosure, so it's a dot dash. Trying to do the best I can with. There we go. So that's our enclosure, and then we have our connectors outside of that, right? Our manifold. So we have 3 or 4 connectors there. So I'll only draw 3 for here. I don't think I'll need all of those either. So at this point, we want to set up a sequencing system, right? So we want to set up a pressure control circuit to, say, compress a cylinder or, say, a device, and then we want to drill it, right? So we want to set up our sequence valves. So when we hit a certain pressure, a certain sequence will happen. In this case, I'll draw first. I always like to draw my control for the system. So here we have our directional control valve, and I'll just draw ours like we have in lab. So we have a closed center. We have our pressure side, and then our side that goes to tank. Side that goes to tank. I could draw another manifold like we have in lab. Maybe I'll do that. Basically, I don't know. Usually you don't necessarily send them again back to. I'll just do this separate, I guess. Tank, we could say just goes. We'll just do it this way. So we're going back to reservoir, right? So we can have multiple reservoir symbols and not have, in this case, 3 reservoirs, right? So that's just a reminder that doesn't necessarily mean we have 3. That just means it's going back to reservoir. We want to hook up our pressure. Move it too far down. Alright, so there's that for our pressure and tanker setup. And we have the 2 sides. So we basically, in one, I might have mixed up depending on how we have those drawn for our lab circuits. It might have been crisscross on the bottom, straight through on the top. But it really, I mean, as long as you have both positions conveyed, it would be best if I probably done it the other way. There's a springs here. Just means if we let go of control of this, it'll move back to our closed center, meaning flow will stop. Oops. Control. Alright, so we want to now hook this up. Maybe I'll bring it down a little bit. And we want to set up our cylinder. So I'm going to draw out, so this is a block we're going to drill. So there's our block we want to clamp, and then we're going to drill and clamp and drill. All right, so we want a cylinder set up to clamp it. So there's our piston, cylinder, linear actuator, and basically has a clamp on this end, just to give you an idea of how that's set up. And then we have, I'll just do port A and port B here for our inputs and outputs on our directional control valve. Alright, so now what we want is we want our drill. Nice if I had a ruler. Should get used to using that one on here, but it definitely make the videos a bit longer. Alright, so here we have the other piston, and say this has our, I don't know how we want to do that, drill here. However to convey that. There might be a better symbol out there to convey a drill, actually. I don't know that one off the top of my head. Let's say our drill circuit. I'll point at it and say drill. So we have a drill here, and that's going to punch a hole in this block. Alright, so essentially what we want, and I'm going to draw out our circuit, how we want this to actually. So here we have, so when we control A, first movement here, right, thinking about the sequence of this circuit, how would we want this to actuate? Well, first we need to actually clamp the block, right? And once we've clamped the block, pressure in our chamber here will build, and once that builds, we're going to push, so this pressure in here will end up pushing this drill down into the block. So that would be, sequence 1 is extend this, sequence 2 is extend this, and then we need to retract it, right? So we don't necessarily want to retract our clamp before we've retracted our drill. So first we're going to retract our drill, so we need to build pressure in this one. That'll bring that back, and then once that pressure is built, we can release our clamp. Because after this pressure is built, that means our drill is fully retracted, right? Because we get a pressure drop on an extension or a volume increase. So when this increases here, pressure will drop until this fully extends, resistance fully blocked by the piston. We'll then send pressure to our next point. So we have, I'll just label the sequence 1. Then we want this one pressurized, so this is 2. Then we want our drill to retract, so that would be our 3rd sequence. And then our 4th sequence would be this chamber here. Right. So thinking about that, we need really two sequence valves, right? So we need a sequence valve here for 1 to 2. So once we build enough pressure here, this one will actuate. And once pressure builds here, this one will actuate. So starting out, before drawing even the sequence valves, what I'm going to do is just hook up the system. So how we did in lab before really adding sequence valves. So say I first want to come out of A, should be connected to that port. And again, we want to build pressure in port 1. Next, we want to build pressure in port 2. So this then needs to go up and over to port 2. Alright, so now we want to retract this. To retract it, we want to push the lever, right? So our lever here will then be pushed the opposite direction. That means our pressure port will then be connected to B. We're going to jump over that cable there. And we want to first connect to our third, right? So we'll build pressure there. And we're going to then connect that to our fourth sequence, is the retraction on our block. So this is the overall circuit connectors, but again, we don't have our sequence valves in, right? We mentioned we had to have sequence valves for this. So I gave myself plenty of room, and this is why I say sometimes it's nice to actually give yourself a little bit of room, do some of the circuit first, think it out first, and then be like, all right, now we need to put in our pressure control. So now our pressure control, we wanted, again, pressure in 1 to build, and then we'll actuate 2. So I'm just going to give myself a little room in here. I'm going to draw my pressure sequence valve. So first we got a directional arrow, right? It won't open up till we've hit a certain pressure. And that's pressure set by our spring. And that pressure has a pilot line. In this case, ours is internal. So I guess I should draw it actually to kind of our inlet point there. So they kind of have it at an angle. And then we have an external drain off of our spring chamber. So we have a dotted drain line that goes to our reservoir. And that's our sequence valve. So say we needed a certain amount of force created for this drill. We can use Pascal's law to figure out how much force we can need basically to get for a pressure and area here. So the area of our actual cylinder, right? We can do that calculation. Well, what does our pressure need to be? Well, pressure is equal to force over area. Or if we're looking for a certain amount of force, we can do force is equal to pressure times an area. So if we know the area of our piston chamber, we can figure out what pressure we needed or for a certain force, right? So this is how we'd figure out, well, how much force does this drill need to actually cut, right? And then we'd set that to say, well, say we figured it out and it's 300 psi. So now this valve will clamp this block, and this won't even open up until it's hit 300 psi, ensuring that we have 300 psi to actually apply here. And as well as it's going to make sure that the block's held under a certain clamp load. So again, you can figure out, well, how much force is actually here clamping the block. All right, so that does our first sequence. So now when we shift it the opposite direction, we want to put another sequence valve in. We have an arrow. And again, we want this to retract first. Oh, actually, sorry, I drew that in the wrong direction. I was thinking. So we're going to be sending fluid this direction, right? So we're going to be filling this chamber here. Filling this chamber. So think about fluid's then going to, so we're now in this, this position, right? So we have pressure coming into B. B is flowing in here. It's going to want to retract this one first and then go to this one. So actually, thinking about that, that's why you always want to kind of draw out these in a specific sequence. So in this case, I'm going to give myself a little bit more room here. I just put that there. And then we're going to put our sequence valve right here. So over here, we're going to have our pilot line. A little close. Right, so there's our pilot line. Other side, we're going to have our spring with the adjustability. And we want to put our relief valve in that direction. And what this allows is now we'll get 3 to happen first, and then once we hit, say, a specific pressure, then 4 will actuate. So this will probably be quite a substantial less force, right? It should be a lot less of a force to pull that out of a block than to push it into one. So maybe this would only be set at maybe 100 psi. Yeah, no reason to overwork the pump on that, pulling that back for pulling the clamp back as well. So what we'll do is under 100 psi it'll start lifting. So basically this will, as soon as this drill is retracted, this will retract, and you can adjust. You know, this would be something you'd probably adjust depending on how it actually functions, and that would then actuate our fourth one. One thing I haven't mentioned yet is that notice how the arrows are pointed in a specific direction, and notice how these are normally closed valves, so they're not normally connected to the open ports. This means flow backwards is basically doesn't happen, or if it does, it's extremely slow and it kind of leaches through the system, and it doesn't work properly. So this is something we'll actually look at in lab, and you'll see the working, different workings of that. But what I'm going to draw now are check valves. So check valves, one-way directional control valves, essentially. So we only want flow to go in one direction. We can do this for reverse flow over top of these valves. So we can do that because we're not opening this valve now in the opposite direction. We're only controlling this in one direction, right? So the opposite flow can be what we call free flow. So all the flow goes around the valve rather than through the valve. So to do that, we just need to draw a quick little box around this, and I'm going to erase that 300 for now. And we have a check ball in here, and we want to make sure we put this in the right direction, right? So I didn't draw the full check ball there. So we're thinking about which direction this needs to flow. We need to open up when we're flowing back this direction. So what that means is we want to actually show the block. It's a V and not really considered an arrow. In this case, we're unblocking. So in this case, if fluid comes this direction, that ball catches and no fluid's able to flow around it. If it goes from this direction, the ball pushes out of the spring. Usually there's some sort of spring. Sometimes it's just a loose system, but sometimes there's a spring there, and that pushes the spring and fluid's able to go around the ball at a rather low resistance. And this is a way to get around these control valves. So you just need to do that really for both of those, or else again you won't be able to operate in a certain direction. So in this one we'll do it over here, and we want to flow again back around that. So we want our catch to be this direction, so it'll actually pressurize when it's going to our fourth sequence there. So in this direction it'll go this way, and again I'll just draw a spring so maybe it'll look a little bit more like, yeah, you're pushing that spring out of the way. But that's our sequence valve there. So that would be how to draw a say clamp and drill circuit. And again, we'll go over the sequence valves, but again, these are closed valves that trigger under a certain pressure. And so once they open, that next portion or sequence can then trigger and happen. So what I would like you guys to do for this this lab here is do a drawing here. Follow the drawing, kind of draw it out. You can draw the drill better if you would like, but please draw the schematic circuits the way I've drawn them. Basically, I just need this circuit here. So just use this as a guide. If you have any questions or issues, let me know. But just take your time. I suggest draw with pencil or something you can erase with, because there's always a mix-up or something. And then I would like you to take a picture and then just post it. All right. So that's lab this week. If you have any questions, again, please feel free to email me. Otherwise, I'll be seeing you guys next week and talking to you in lecture here in a few minutes. All right. Later.